to Study Sprint. In today's video, we are going to be looking at converting fractions to decimals. It's easy to convert fractions that have 10, 100 or 1000 as a denominator. For instance, we have the fraction 23 over 100. Since the denominator is 100, it means that the decimal will be up to the 100th place, which means that 23 over 100 is equal to 0.23, which can also be read as 23 hundredths. Now, because our denominator had two zeros, we are moving the decimal point 2 places back, so that makes it 0.23. Now, what if the denominator is not in the power of 10, like 3 over 5? So for that, I'm first going to show you the first method. Step 1 is to think of a number that can be multiplied to the denominator to make it a power of 10. So for example, with a denominator of 5, we can multiply it by 2, which is going to equal 10, because 5 multiplying by 2 is 10. Step 2 is to multiply the top and bottom by the number you got from step 1 to find an equivalent fraction with a denominator of 10. So for example, in the fraction 3 over 5, we are multiplying 5 by 2 to give us 10. So we're going to multiply 3 by 2, because to make an equivalent fraction, we multiply the denominator and the numerator by the same number. So 3 times 2 is equal to 6 and 5 times 2 is equal to 10. So the equivalent fraction for 3 over 5 is equal to 6 over 10. And now once we have got 10 in our denominator, it's going to be very simple to convert this into a decimal. Because we have 10, we're going to take the decimal point one place behind. So that would be 0.6 or 6/10. Our second method is called short division. Let's look at an example question. Use short division to write 7 over 8 as a decimal. Now, short division is the most common way used to divide fractions to give an answer as a decimal. So in short division, what you simply do is that you divide the numerator by the denominator. So we are going to put these numbers under a dividing bar. 7 will go inside because it's being divided by 8, which will come outside. Now, if you look at this, you can see that we cannot take 8 out of 7 because 7 is less than 8. So what we do is we add a decimal point after 7 and then a 0. Now for now, if you ignore the decimal point, this number is 7070. So we know that we can take 8 out of 70. So 8 times 8 is 64. 70 minus 64 is equal to 6. Now again, 6 is less than 8. So we're going to add another 0 and bring the 0 down to 6. So that will make it 60. Now 8 times 7 is 56. And 60 minus 56 is equal to 4. Now again, 4 is less than 8, so we're going to add a 0 and bring that 0 down next to 4. Now 8 times 5 is equal to 40. And 40 minus 40 gives us a 0. So up till now we have got 875. We still have to bring this decimal point up. And before this decimal point, we're going to add a 0. So the answer would be 0.875. A quick tip is that you can tell which kind of decimal, terminating or recurring a fraction will give by looking at the denominator of the fraction in its lowest term. If the only prime factors of a denominator are 2 or 5 or both, then the fraction will become a terminating decimal. If the denominator has any prime factors other than 2 or 5, then the fraction will become a recurring decimal. So let's look at an example for both the types of decimals. An example for terminating decimal could be the fraction 1 over 20. So when you prime factorize 20, we get the factors 2 and 10. 2 is a prime factor. Then we carry on dividing 10 and we get 2 and 5. So in this case, because our prime factors are 2, 2 and 5, so our answer is going to be a terminating decimal. So the decimal for the fraction 1 over 20 is equal to 0.05. Now let's move on to recurring decimal. An example for recurring decimal is the fraction 1 over 6. If we find the prime factors of 6, we get 2 and 3. Now because 3 is other than 2 and 5, that means that the decimal for 1 over 6 is going to be a recurring decimal. So the decimal for the fraction 1 over 6 is 0.16666, and this never stops. That is why we call it a recurring decimal. Now let's take a look at a practice question. Write down 22 over 25 as a decimal. Now this question can be done in different ways. Either you do it by making the denominator a power of 10, or you do short division. But multiplying is easier than dividing, so when we have the option of multiplying, we're going to multiply. So 22 over 25. Now we know that 25 multiplying by 4 will give us 100. And to make it into an equivalent fraction, we have to multiply the numerator by the same thing as we multiply the denominator. That makes it into 88 over 100. Now when we have a power of 10, we're going to look at the number of zeros. We have 2 zeros, so our decimal point is going to go 2 places back. So that is going to equal 0.88 or 88 hundredths. Our next question is, write 9 over 30 as a decimal. Now if you look at this fraction, you can see that 9 and 30 are both divisible by 3. So we are going to simplify them first to make our calculations easier. So we know that our fraction is 9 over 30. And 9 and 30 both are divisible by 3. 9 divided by 3 is 3, and 30 divided by 3 is 10. Now we have a power of 10. So that means we're just going to move the decimal place according to the number of zeros that we have. Because we have 1 0, we're going to move our decimal point 1 place back. That means it's going to come before 3. So our answer is going to be 0.3. The second tip is, if you can find an equivalent fraction with a denominator of 9, 99, 999, etc., then the numerator gives you the repeating group, which will have the same number of digits as the number of 9s in the denominator. So what this means is that when you have a fraction, for example, 13 over 99, and you have 99 or 999 or 9 in the denominator, what you do is you count the number of 9s and move the decimal place that many places back. So when we have the power of 10, we used to count the zeros. In 9s, we count the 9s that we have. So we have 2 9s, so we are going to go 2 steps back, which will equal 0.13. Now our practice question is, write following fractions as decimals. A, 1 over 9, B, 7 over 99, and C, 4 over 999. A is 1 over 9. we only have 1 9. That means our decimal point is going to go one step back from 1. So that would be over here. So answer would be 0.1. Part B is 7/99. Now we have 2 9s. That means that our decimal point will go 2 steps back from 7. 1, 2. Our decimal point is going to be here, but what about our first step? Well, on our first step, you're going to put a 0. So our answer would be 0.07. Our third part is 4/999. This time we have 3 9s. That means that our decimal point is going to go 3 steps back from 4. 1, here we have a 0, 2, another 0, and 3, our decimal point. So our answer is going to be 0.004. Our second practice question is, write 2/3 as a decimal. Now we are going to do it by 2 different methods. First we are going to do the short division method, and then we are going to turn 3 into 9. To do this question by the short division method, we are going to make a dividing bar, put 2 inside and 3 outside. Now we know that we cannot take any 3's from 2's, so I'm going to put a 0, a decimal point, and then a 0 next to 2. That makes it 20. Now I know that 3 times 6 is 18, and 20 minus 18 is 2. Again, 2 is smaller than 3, so I'm going to add a 0, bring that 0 down, that makes it 20. Again, 3 times 6 is equal to 18. 20 minus 18 is again equal to 2. So I can see that every time a remainder is 2. That means my answer is going to be 0.666 recurring, and this will not stop. Now let's do the same question but using the second method. So our fraction is 2/3. And now we're going to make our denominator a 9. So 3 multiplying by 3 will give us 9 in the denominator. To make it an equivalent fraction, we have to multiply the numerator by 3 too. So 2 multiplied by 3 is equal to 6. Now because we have only 1 9 in the denominator, our decimal point is going to go one place back. So our decimal point is going to come before 6. So our answer is going to be 0.6. Thanks for watching. If you found this video helpful, give it a thumbs up and share it with others. For more updates, please subscribe to my channel and don't forget to click the notification bell.